Function problems and symbol problems are two categories of questions that on the surface can look very intimidating. However, they're really nothing more than simple algebraic substitution. In a symbol problem, the question introduces an unusual character or a previous math symbol but gives it a new definition. So in this case, they have the spade symbol and they tell you what the spade symbol means. To simplify the symbolic expression, I will take the variables and I'll read them to myself as the first number and the second number. So I would read this expression as, when you spade two numbers, all you do is you take the first number and subtract the second number, and then multiply that times the first number plus the second number. So that if the question asks me to figure out what is 4 spade 5, I'm just going to treat the 4 as my first number and the 5 as my second number. So then my problem becomes my first number minus my second number times my first number plus my second number. And then I just do the math the same way I would for any other problem. So I get -1 times 9, or -9. Sometimes a student can get tripped up if they see a symbol and they mistake it for another math symbol they're already familiar with. So in this case, I've seen students interpret this as m dot 9, which is another way of writing m times 9. But this phrase in the beginning of the question, the operation star is defined for all m and n, that phrase is letting you know they're setting you up for a symbol problem. So we're going to treat it exactly like our last symbol problem, labeling our variables as the first number and the second number. The second part that makes this one a little bit more confusing is that we've actually got the symbol used twice, once inside parentheses. When you see parentheses in a symbol problem, they mean the exact same thing they do in every other math problem. That is, you do what's inside the parentheses first. So we're first going to figure out what -3 star -2 is. And the instructions say I just take my first number and then I square it and divide it by my second number. So I get -3 squared, and then I divide that by my second number, -2, or 9/2. Now I take 9/2 and I plug it into the parentheses. So I could rewrite the problem as 6 star 9/2. And then I follow the exact same set of instructions as before. I take my first number, that's my 6, I square it, so I get 36, and then I divide that by my second number, which is 9/2. Then I simplify by flipping and multiplying by my denominator, and I get 36/1 times 2/9, which is 72/9, or 8. Let's try one more. This time they define x to the star as x to the star is equal to pi divided by x. And the way that I'm going to read that is, when you star something, all you do is you take the number pi, which is 3.14, or we can just leave it as a symbol pi. But when you star something, the instructions say to take pi and then divide it by x, or divide it by the thing that you starred. So for example, if I had 4 raised to the star, all I'm going to do is take pi and divide it by the thing that I starred. Now they want us to apply the star to this complicated problem over here, but it should be simple as long as we follow it step by step. So just like regular math, I'm going to start with what's inside the parentheses. So I have -pi to the star, and the instructions say when I star something, all I do is I take pi and then I divide it by the thing that I starred, which in this case I starred a -pi. So I get pi over -pi, and that's equal to -1. Now I take that -1 and I plug it into the parentheses where I found the -pi to the star, and I can rewrite that new equation as -1 raised to the star. And then I repeat my steps. So when I have -1 to the star, all I do is I take pi and I divide it by the thing that I starred, or I get pi over -1, which is the same thing as -pi. So you can see symbol problems really aren't hard. They're almost a test of whether or not the exam can scare you and whether or not you can follow step-by-step instructions. Function problems are going to be extremely similar in that they look a little scary, but they're really nothing more than substitution. When I have this symbol here, which we read as the function of x, all I'm really saying is take whatever you put inside the parentheses and then substitute that in for x. So if a problem said the function of x is x plus 1 over x minus 1, and then said what is the function of 3, all I'm doing is plugging 3 in wherever I see x. So I would rewrite the equation as 3 plus 1 over 3 minus 1, which is the same thing as 4 over 2, or just 2. This problem might look a little more complicated because inside the parentheses I also have an x next to a positive 2, but it doesn't change my steps. All I'm going to do is take what's inside my parentheses and plug that in for x. So then I write my new equation as x plus 2 plus 1 over x plus 2 minus 1, which simplifies to x plus 3 over x plus 1, and there's nothing more I can do with that. So that's my final answer. If you get a function inside of another function, we're going to use the exact same idea we used with symbols when we found parentheses in a problem. And that is just focus on what's inside the parentheses first. So in the inside I have the function of 2. So I take my 2, plug it in for x, and I get 2 plus 1 over 2 minus 1, which is equal to 3 over 1, which is just 3. Next, I take that 3 and I plug it back into my parentheses. And I rewrite the question as now the function of simply 3. And then follow the same steps I did before, just take 3 and plug it in for x. So I write my equation as 3 plus 1 over 3 minus 1, or 4 over 2, or just 2. This problem here confuses a lot of people. But just like we saw in symbols, the math is not hard. It's just a matter of understanding what the question is really asking. Remember that what goes inside the parentheses is what you substitute in for x. So what this question is asking is, which of the following equations gives you the exact same answer whether you plug in 0 or 1? And there's no shortcut to do this. You simply have to plug 0 and 1 into every equation. So if I start off with the first equation, x plus 1, I can quickly see that 0 plus 1, because I took my 0 and plugged it in for x, that is not going to be the same thing as when I plug in 1 for x, or 1 plus 1. 1 is not equal to 2. So A is definitely out. On answer choice B, when I plug in 0, I can rewrite x to the x as 0 to the 0. And you'll remember that from our exponents video, anything raised to the 0 power, that is equal to 1. And then if I take 1 and plug that into the same equation, I get 1 raised to the 1 power, which is also 1. So B is my answer, because I both get the same answer of 1 whether I plug in 0 for x or 1 for x.